Computational thinking is looking at problems or looking at systems in such a way that a computer can help us solve them or help us understand them. Somebody who's thinking computationally is going to be drawing on a number of concepts there. I'd include logical reasoning, algorithms, decomposition, patterns or generalization, as well as fundamentally abstraction as part of that list of concepts. The computational thinker, though, is also likely to be involved in a number of different processes, and that's going to range from tinkering through to making and debugging and working collaboratively and being willing to persevere when things perhaps aren't working as well as they might be. For me, programming is a two-step process. We first need to think about the problem, to understand the system. The notions of computational thinking come in there. And I'd include working out the algorithm for your program as part of that. And the second step is then to translate that algorithm, that way of solving the problem, into a language which the computer can understand. And we call that coding. So for me, programming is made up of algorithms and coding. Can you have one without the other? Well, yes, I suppose so. Making a jam sandwich, we might have an algorithm for that. And if we're working in HTML, we're working in a language which the computer can understand, the language of code. And there's no sense in which we're coding an algorithm there. But I think the two work particularly effectively when they work hand in hand, when we are actually teaching the whole range of programming, from how do you solve the problem, thinking about those steps, the algorithm, to then translating that into computer code, into the language which the computer can understand. I think it's important that young people realise that there's more than one language that you can use, and indeed there's more than one algorithm typically that you'll be able to use in order to solve a problem. But for any particular algorithm, we can often translate that into lots and lots of different computer languages or code, if you want. Well, curriculum design is something which really ought to be left up to individual countries or perhaps even individual schools to decide. When you're thinking about what to put onto a school curriculum, whether it's primary or secondary, I think you can be guided by William Morris's advice on interior design of all things. He said, don't put anything into your house unless you know that it's useful or believe that it's beautiful. And for me, that's a good rule of thumb when it comes to curriculum design, that we should teach in school things that we know our young people are going to find useful, but also things which we believe in our heart of hearts they'll find interesting. And I think coding, programming, if you will, is something which is both useful and interesting. Should it be taught in primary schools? Well, for me, yes, I would say so, because my vision or my hope is of everyone learning about code, learning how to code. And I think the sooner one starts that journey, the more likely you are to have everybody arriving at that destination. We know if we leave it until university level or perhaps even upper secondary level that there will be a number of young people who find this really very difficult, and perhaps even I might admit beyond them. If we start early enough though, just as we do with music or with poetry or with painting, I think we have a reasonable hope that everyone will be able to do that. So in England, we're starting our youngest pupils programming little floor-shaped, little bee-shaped robots that trundle around the floor. Can everybody learn how to program a bee-bot? I think so. Certainly by the age of 7, every child in an English primary school can learn how to do that. If they can do that by the age of 7, then by the age of 11, there's a very good chance that they'll be able to learn how to make their own computer game or draw their own pictures using a language such as Scratch. And if they can do that by the age of 11, then I think we have a really good chance that they'll be able to learn a sophisticated text-based programming language like Python to do something useful with real-world applications by the age of 14. At least I hope so. I'd hope that every time teachers are teaching coding, they're doing so in a creative way, and more importantly, in a way which encourages young people to develop their own creativity in this medium. Imagine, if you would, a first language curriculum which just focused on reading and never provided an opportunity for writing. I think we'd see that as a tremendously impoverished curriculum. And so coding a programming curriculum or a digital literacy curriculum which just focused on using software and never provided the opportunity for young people to write their own software would seem a terribly impoverished sort of thing. Another analogy, if you would, think of art or music or poetry education. Can you teach those in such a way that young people never work creatively? Well, I suppose you could. You could read other people's poems, you could listen to other people's music, you could admire other people's art, and there certainly is a place for those things. But in each of those domains, I think most of us would say that education really should include the opportunity for young people to work creatively in those media. And I'd say exactly the same applies to coding. Yes, of course, computational thinking provides a way of understanding the world around you, but it also provides the opportunity to change that world through working creatively through the medium of code. I don't think coding really deserves to be called the new literacy. I think being able to read, being able to write are much more important than being able to write code. It's hard to imagine any pupil ever getting a job writing a Scratch program. Python perhaps, but not so much Scratch. So no, it's not the new literacy. It is, however, tremendously important. Digital literacy is something which is approaching literacy as essential for learning and life. Being able to use a computer, being able to type up an essay, being able to write a letter online, being able to make a presentation, or indeed make a video, being able to find information when you need it effectively and accurately using Google, Bing, or any other search engine. Those are pretty close to essential digital literacy skills. I don't think coding quite merits a place on that list just yet, but it does provide tremendously important insights into those tools, those techniques. So just as we would want the student of language to know a little bit more than merely how to be able to read and write, we'd want them to understand something of how language works. So I think code allows us to go beyond the mere functional skills of digital literacy into some understanding of how digital technology works and its place in the world around us. My message to EU Code Week ambassadors is firstly, thank you very much. It's hugely important, the work that you're doing, providing opportunities for young people to learn about programming, to learn about computer science, and to pass on something of your enthusiasm, your experience to the next generation. I think working together as a union, as a European community, provides so many opportunities for collaboration, from learning from one another's insights. And I'm sure you will all have seen that as a group of Code Week ambassadors. But so too can we provide those insights to our young people. And it would be lovely to see opportunities in EU Code Week and beyond for young people across Europe to work together on software projects, as we see in so much open source development of developing complex software products which transcend national borders.